Hi everyone, this is Sachin Kumar. Today we are learning about the nature of continuing the previous lecture only. How this nature of concentration profile varies with the diffusion coefficients for binary ternary systems, and we have completed for the binary systems. We are in the middle of the ternary systems. Concentration profile for ternary system. So, in previous class, I talked about, explained the concept of and the properties, main features of ternary system. So, sorry, I had to write the opposite direction so that it will be balancing. So, this is the kind of profile that we will obtain for the ternary systems, and we say that these ternary systems are shows inverted symmetry and same diffusion depth for the on the both the sides, same diffusion depth for the two components, and the third one is, and there is no peaks here, and this is for the diffusivity value 4.5. It's 3 to 1, 0.6, 1.7 to 2 into 10 power minus 50 for all of us, for all division coefficients. So when we are changing the main interdivision coefficients, these two, so what will happen to the concentration profiles? So consider, if I change this 4.5 into some quantity, that is 64, and the remaining values as it is, then what will happen to the concentration profiles? This concentration profile will increases. For example, here it is initially 30, 30 minus plus 30, but the as we see that diffusion coefficient is increased, and the diffusion of the atoms is also more in the same concentration gradient, then we can see diffusion depth is also increased. increases the main diffusion. Main inter diffusion coefficient than diffusion depth increased of component 193. Okay, this is the main thing that we will get a conclusion from the concentration profile. So one more important point I want to note here is, here the concentration, this is C1, this is C3 and this is C2. This C2 is concentration is same from left hand to the right hand. So what's the reason behind this one? Reason for this one, so I have to write a flux for J2 first. This is cross coefficient, this is main coefficient. Consider this value as minus 0.6 into 10 to the power minus 15, 22, so 1.75 into 10 to the power minus 15, both is meter square per second. The cross coefficient are much smaller as compared to that of the main interdiffusion coefficients. Hence the cross effect is negligible, and this, because of this one, it's almost flat. So here it is, we can see this is a cross coefficient, this is a main coefficient. The cross coefficient smaller than main interdiffusion coefficient. Compared to the main interdiffusion coefficient. Due to this reason, it's a flat. Here, if cross coefficient is different, is very small, then the effect of concentration gradient of another component is not at all affecting to the flux of one component. That's why the concentration is same. Next, we are jumping into the concentration profile which contains the peaks. I'll write the one point seven, 10 meters per second, and these are having the concentration profiles. So see, this is for C3 minus, C3 plus, C2 minus, C2 plus, C1 minus, C1 plus. Okay. So these two C1 and C3 are having the same concentration profiles, but we can see here in C2 there is a changes. We are seeing the small peaks on the concentration profiles. So why the main reason for this peaks is, in this case we are increasing the magnitude of the cross coefficients, hence it has effect of the flux J2. Therefore C2 minus component 2 will shows the variation in the maxima and the minima. If we are increasing the magnitude of cross by mistakenly went gone. So instead of that one, I will write it complete only the sentence that we are missing here. Why the component 2 showing maxima and minima. The answer for this one is, so we are so cross coefficients are cross coefficient for component 2 are increased, hence flux of 2, that is J2, is affected. Therefore C2 component will show variation with maxima and minimum. That means the interaction of an atom is more. The component 2 will interact with component 1 and 3 is more. Because of this one, it is showing the maxima and minima. Okay, this is all about the nature of concentration profiles in binary and ternary. So in this lecture, we saw already saw the how this concentration profile will varies, how this the diffusion depth will varies by varying the diffusion coefficients. Okay, next we are moving into the some important equations or solution that are obtained from the solving the continuity equations. I will it requires this derivation requires a lot of time, so we are considering only the now we are considering only the equations. I will write the equations for all the conditions, then if possible I will take one of the derivation. Okay, first comes the instantaneous planar source. Planar source. By solving the continuity equation, we got the equation into delta root phi dt exponential minus x square divided by 4 dt. By taking ln on both sides, ln c equal to minus x square divided by 4 dt plus ln of delta root pi dt. When we draw the graph between ln c and x square, we'll get it as straight line with a negative slope. The slope is 1 by 4 dt. Okay. So when we are considering the second case, solution for the diffusion equation for the semi-infinite slab. Solution for solution to diffusion equation for semi-infinite slab. Slab so solution is C into CS, C equal to CS into 1 minus error function x divided by 2 into root dt. This is very important. This will use the, so if we given the time x value 2 into root d into t, so if we given the time, and the coefficients, the diffusion distance can be calculated. Okay, this is the one of the importance of this one. For example, x1 t1 x2 root 2 into d t2. So we know that this 2 get cancels, dt get cancels, x1 by root t1 equal to x2 by root t2. For the uh, same component having the diffusion value is same, d value, then the with the time t1 how much diffusion will take place, with time t2 how much diffusion will take place, we can correlate with each other. Third case is solution to the diffusion equation for the binary diffusion couple. Solution to diffusion equation for binary diffusion couple. Correct? Yes. So this looks like simple thing that we have seen previously. This is one concentration, this is another concentration. c minus c plus. By variation we can get it as c of x comma t minus c plus c minus c plus equal to 1 by 2 1 minus error function x by 2 into root d. So these are the three main equations that we are obtained by solving the diffusion continuity diffusion equations by applying the boundary conditions. Okay, so these are the three main equations, and I will solve in the next upcoming video. I will solve one of the equations. Maybe this instantaneous planar source I can explain with the derivation. How we are obtained this equations. So what is its important? I will explain this. Okay, today's class is over. Thank you.